Hi guys, this is Warner here. Today we're going to do roots and radicals, notes number 5. We're going to do the quadratic formula, everybody's favorite. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. It will help you find the roots or what the value of x is in the quadratic equation. So it's actually solving for the value of x, and since it involves a radical, it's in the radicals chapter. That's so crazy. Okay, so, that didn't work very well. Neither did that. Here we go. Okay, so let's look at our first example that we have. And our first example is n squared minus 5n minus 9 equals 0. So if you notice this, ax squared plus bx plus c equals 0. That is the actual quadratic equation, where up above, this is the actual quadratic formula. So what I like to do is line up underneath here, ax squared plus bx plus c equals 0. And in the first case, somebody just gave me a Mother's Day card. In the first case, our a is in front of the n squared, and a is a 1. And in the next part, the b is in front of the n, so our b is negative 5, important to bring your sign with it, and c is going to be negative 9. Okay, now we just fill them in the actual formula. So back up at the top, we have x equals negative b. Well, that's negative 5, so we know that's going to turn into a positive. Then we write plus or minus square root of b squared. Well, b is negative 5 squared minus 4, a is 1, and c is negative 9, divided by 2 times a, which is 1. So the first step is to substitute all your values for a, b, and c in the appropriate spots in the formula. Now we're going to actually do the math, and we're going to work from left to right by using PEMDAS. So negative 5 is positive 5 plus or minus square root. Negative 5 squared. Be careful when you enter that in your calculator. You got to use the parentheses. That gives you 25. When you multiply two negatives, it gives you a positive, and 9 times 4 is 36 divided by 2. Now add those two numbers underneath the square root together. So 25 and 36 is 61 divided by 2. And at this point, you look at the square root of 61 and say, can I simplify that? Heck no, it's prime. So this is my final answer. The two roots that are there, or the two values of x, are 5 plus radical 61 divided by 2, and then 5 minus radical 61 divided by 2. That was our first example. Okay, let's check our next one. So now we have ax squared plus bx plus c equals 0. In this case, a is 2, b is 4, and c is negative 3. Okay, we're now going to take and fill them in. So negative, internet must have slowed down, negative 4, that's a 4, plus or minus square root of 4 squared minus 4, a is 2 and c is negative 3, divided by 2 times a, which is 2. Okay, remember, work from left to right using PEMDAS. So that's going to stay negative 4 plus or minus square root of 16, because 4 squared is 16. Two negatives turn that into a positive, and 4 times 2 is 8 times 3 is 24, divided by 4. So now I have x equals negative 4 plus or minus the square root of 40 divided by 4. Okay, now, last time we left the 61 because it was prime, but 40 will divide by a perfect square. And that perfect square is 4 times 10. I'm so excited. So we're going to break down our radical to be radical 4 and radical 10 But we know that really is a 2 radical 10 over 4. Now, we're still not done. Once we have all of that radical broken down, we're going to look at the numbers on the outside of the sign, not go inside the radical because he's different, he's in jail. But they all divide by a 2, correct? So I'm going to divide each of these numbers by 2. So this final answer is -2 plus or minus 1 radical 10 or just radical 10. All of that divided by 2. And there is my simplified answer. I had to simplify because all 3 of those terms on the outside of the radical divided by a GCF of 2. Okay, that was fun. Let's look at our last example over here. Can I get back up there? There we go. Okay, so on the last example, there's a problem. See that it's not written in proper form, so I actually need to multiply that out. That's really 5x squared minus 7x, and that 6 is on the wrong side. It has to say equals 0, so I'm going to subtract 6, so it equals 0. The 6 needs to be on the other side. Now I know I have ax squared plus bx minus c equals 0. A is 5, b is -7, and c is -6. Oh boy, I'm going to run out of room. Okay, here we go. X equals -7 plus or minus square root of -7 squared minus 4. A is 5 and C is -6. Divided by 2 times 5, which is 10. Now I have 7 plus or minus square root of 49. The 2 negatives are going to turn it into a positive 120 divided by 10. And this time, if I add the numbers together underneath here, that gives me the square root of 169, which is actually a perfect square. So now I have 7 plus or minus 13 divided by 10. I can actually get 2 numerical answers for this. So it's going to be 7 plus 13 divided by 10, or 20 divided by 10, which is 2. And then I'm going to do x equals 7 minus 13 divided by 10. 7 minus 13 is -6 over 10. And if I reduce that, that's -3/5. So -3/5 and 2 are my 2 answers. That was super fun, friends. And that concludes our lesson on the quadratic formula. So this week we just wrapped up our roots and radicals chapter. We had the quadratic formula. You have a nice little review for your unit test and take your test in eDoctrina this week. I would highly suggest using your review to complete your test. All right, guys, have a great day. And one made me over there. I have fun. Oops. Bye now.